Hello, I'm Aishwarya V from Cybersecurity. Today I'm going to speak a topic from waste management, optimizing hazardous waste management strategies, minimizing the production, treating the toxicity, and implementing the engineering controls. As we further speak about the introduction, in this presentation we will explore optimizing hazardous waste management strategies to minimize the production, to treat the toxicity, and to implement engineering controls. We will discuss the importance of sustainable and responsible waste management practices in various industries. Understanding the hazardous waste. Defining the hazardous waste and its classification according to regulatory standards. Exploring the environmental and health risks associated with the improper disposal. Analyzing the economic and legal implications of mishandling the hazardous waste. Hazardous waste management rules are notified to ensure safe handling, generation, processing, treatment, package, storage, transportation, use, reprocessing, collection, conversion, and offering for sale, destruction, and disposal of hazardous waste. Minimizing the waste production. Strategies for waste minimization through processes optimization, material substitution, and recycling. Case studies showcasing the successful waste reduction initiatives in diverse industrial sectors. Waste minimization is reduction in the quantity of the hazardous waste achieved through a conscientious application of innovative or alternative procedures. Simple adjustments to a process producing waste, for example, a teaching lab experiment, a vehicle cleaning operation, etc. Treating the toxicity. Examining the advanced treatment technologies for hazardous waste, including thermal treatment, chemical stabilization, and biological remediation. Evaluating the effectiveness of these methods in reducing the toxicity. Further chemical methods they include ion exchange, precipitation, oxidation, and the reduction and neutralization. Among the thermal methods is high temperature incineration, which not only can detoxify the certain organic waste but can also destroy them. Implementing the engineer controls. Utilizing the engineer controls such as containment systems, ventilation, and filtration to minimize the exposure to hazardous waste, and highlighting the best particles for engineering design in waste management facilities. Engineer control methods that can be used to reduce or eliminate the lead exposures can be grouped into three main categories: substitution, isolation, and ventilation. Engineering controls are the first line of defense in protecting the workers from hazardous exposures. Regulatory compliance. Navigating the complex landscape of regulatory requirements for hazardous waste management. Understanding the role of government agency and the international standards in ensuring the compliance and the accountability of waste management. Regulatory compliance, it requires companies to analyze their unique requirements and any mandates specific to that industry and then develop processes to meet these requirements. Typical steps to achieve the regulatory compliance they include the following: identity, applicable regulations. Effective solutions. Exploring the cost-effective approaches to hazardous waste management, including the life cycle assessment, resource recovery, and collaborative industry partnerships, demonstrating the long-term economic benefits of sustainable waste practices. It is a measure of how well the resource used are aligned with the results achieved. A cost-effective solution is one that achieves the desired outcome while using the least amount of money. Even when costs are high, a business can still be cost-effective. Risk assessment and mitigation. Conducting the comprehensive risk assessments to identify the potential hazards and the vulnerabilities in waste management processes, implementing the proactive mitigation strategies to minimize the environmental and the health risks. Risk assessments they involve measures processes, and the controls to reduce the impact of risk. Prioritize risks. This steps involves ranking the quantified risk in terms of severity. One aspect of risk mitigation is prioritization, accepting an amount of risk in one part of the organization to better protect another. Employee training and safety. Prioritizing the employee training and safety protocols to ensure proper handling and disposal of hazardous waste, emphasizing the importance of a safety culture within the organizations to prevent the accidents and exposure. Community engagement, engaging with local communities to foster the transparency and the address concerns related to hazardous waste management, and building trust through open communication and proactive involvement in the community initiatives. Future trends and innovations. Exploring the emerging technological innovations and trends in hazardous waste management, such as advanced monitoring systems, nanotechnology applications, and predictive analytics, anticipating the future challenges and the opportunities in the field. Conclusion. In the conclusion, I would like to conclude by saying that optimizing hazardous waste management requires a multifaceted approach that integrates waste minimalization, toxicity treatment, and robust engineering controls. By prioritizing the sustainability, compliance, and the innovation, organizations can achieve responsible waste management practices while safeguarding the environment and the public health. Thank you.